Today we're going to take a graphical look at our radical functions. I've got the parent function here, y equals the nth root of x. Remember, n can be any number, 2 through whatever, but the radical functions act a lot like the power functions. They separate themselves into an even group and an odd group. So the square roots, the fourth roots, the sixth roots, the evens tend to look one way. The odd roots like third, fifth, seventh tend to look a little different. So they separate themselves into two groups, but their characteristics are the same. So here's all the things that we can do to this parent function and what they mean. The k at the end is a vertical translation. Positive is up, negative is down. H is a horizontal translation, but this radical symbol is a type of parenthesis. So things inside of this radical are backwards. Positives go left, negatives go right. The negative out front would reflect this over the x-axis, and the a changes the slope, for lack of a better term. If it's bigger than 1, it's going to just stretch it, make it taller. If it's between 0 and 1, it compresses it. Don't confuse the negative with the a, they are separate things. The a does the reflecting, or excuse me, the negative does the reflecting, the a changes the stretch or compression. As far as graphs go, all radicals have this part of the graph, the evens and the odds. If you have an even, this is where it ends. It just starts at 0 and goes up and to the right. If it is an odd radical, like a third or a fifth, not only does it have one that's going up, but it has one that's going down. And the reason for the difference is I can take cube roots and get negative answers. I can't take square roots and get negative answers. I can't take the square root of a negative. So that's why we only look at the positive side here where the x's are positive. With the odds, we add on that other piece, kind of like that S shape or that chair curve from when we talked about power functions. Here's the basic square root. Notice I only drew the 1/2 of it. I did not draw both parts. And we made some changes. If I put a -2 on the outside, that moves it down 2. If I have the +1, that moves it up 1. If it's inside that radical symbol, this actually goes left 4 because it's backwards, it's a set of parentheses, and the -3 actually moves it right 3. Again, backwards because it's in that radical side, which is a type of parenthesis. Now we can start combining more and more things and pick them out. You can always look at these graphically, but we're going to attack them algebraically today. I've got a +1, that moves me up 1. I've got a -3 inside, that's going to move me right 3. Two things going on here in front, and I need to realize that they are separate from one another. The negative is a reflection over the x-axis. The 1/2 changes the steepness. It's kind of like a slope, but because it's smaller than 1, but still bigger than 0, this is a compression of 1/2. For number 3 up here, we don't have the negative, but we do have a number. This is a stretch. It's being stretched by 3. I have some movements. I have a down 2, and I have a left 4. Again, make sure you're switching the sign on that. Inside the radical symbol means it works backwards. Now, we can do some solving graphically since we're talking graphs here. I have this square root of x minus 2 equals 3. I could graph these two things. Graph them separately. Y equals the square root of x minus 2 and y equals 3. So if you are big into graphs, if you are very visual, you can graph both of these and see where they cross. You can still solve these the traditional way, square both sides, and then finish solving this out. But either way, I'm supposed to take a square root and get 3. The only way that works is if I have a 9. So x ends up being 11 because 11 minus 2 is 9, and the square root of 9 is 3. So a couple ways you can attack those radical problems. Now let's take a look at the odd roots, like a third root. The nice thing about these cube roots is they work the same way. The only difference is what our graph looks like to start. We still have the positive portion of that root, but we also have a negative portion. So both parts are going to move up or down, left and right, be stretched, compressed, things like that. My first example here, I have a -1 under the radical, so that's going to move right 1. Outside the radical, up or down, and it follows just like it is. Here I have a 1/2 being smaller, so this is actually a compress by a half. My next one has a 4 in front, that's a stretch. But I also added the negative, so it also has a reflection over the x-axis. So today we're picking out those pieces and trying to figure out how this parent graph got changed. And we can throw them all together. This has a 2, that's a stretch. The -4 on the outside, that's down 4. And the +1 on the inside, that is left 1. You can do this algebraically, no problem. You can also graph them and physically look at them and see how this graph has been changed. The last thing I want to tackle is what happens if we get some radical that doesn't fit the patterns we've been doing so far. If I look closely inside of this root, 9 and 18 can be broken down. They have something in common. And it's interesting because what they have in common is something we can actually take the square root of. If I take a 9 out of both parts, I can do the square root of 9, and I get 3 times the square root of x minus 2, and it looks just like the problems we've been doing. This has been moved to the right 2, this has been stretched by a factor of 3. Now if I'm thinking, or if I'm dealing with a cube root, I have to think in terms of cubes. So yes, I could definitely take a 4 out of these, but 4 is a square root. So I have to take out something that is a cube root. They both have a factor of 8, and 8 is a cube root. So if I do a little factoring in here, I can do the cube root of 8, and I get 2. And now this problem lays out just like the previous ones. It's been moved down 2, it's been moved to the right, to the left 4, and it's been stretched by a factor of 2. Not as easy to see those things when it's written this way. That's why we try to simplify our radicals before we pick out those pieces.